So hello everyone, welcome back to School Coaching Point. In the last video, I have given some explanation of from the topic relation and function. So I have explained the definition of relation and the types of relation, basically the reflexive, symmetric and transitive relation. So today we will discuss one important questions from the exercise relation and functions from class 12. So this is the question in front of you. So here E is the main set. The set is given 1, 2, 3, 4 till 14. And R is, what is the relation given? R is x comma y. So we need to take the order pair in such a way that 3x minus y equals to 0. So this is the main condition given. Now 3x minus y equal to 0. So can you consider 3x minus y equals implies as 3x equals to y? It's exactly same. 3x minus y equals to 0, we can write as 3x equals to y, because after transposing y to the right hand side, it becomes what? 3x equals to y. So that means this is the main condition to write down the relation. Now we need to consider the values of x. So what are the values of x? We need to consider from the set A. That means starting from the element 1 to till 14. Now for x equals to 1, if x equals to 1, then what should be the value of y? 3 into 1, it will be 3, because y equals to 3x. So once you're taking the value x equals to 1, it will be what? 3 into 1, it equals to 3. That means, what is the first order pair? 1, 3. Yes? 1, 3 is the first order pair. For x equals to suppose 2, then what will be the value of y? It will be 3 into 2, it will be 6. If x equals to 3, then what is the value of y? 3 3s are 9. If x equals to 4, then the values of y will be 4 3s are 12. X equals to 5, the values of y is 15. But x equal to 5, y equal to 15. We cannot consider this order pair. We cannot consider this order pair. Yes? Why you cannot consider this order pair? Because here the values are till 1 to 14. Till 1 to 14. And x and y, this x and y, it should be belongs to 1 to 14. X and y, it should be belongs to the set A. That means x, it may be takes from the value 1 to 14. Y maybe take the value from 1 to 14. So since here after taking x equals to 5, we get y equals to 15. Since the values are from 1 to 14, so we cannot consider this order pair 5, 15. That means what are the order pairs? 1, 3, then next 2, 6, 1, 3, 2, 6, then 3, 9, 4, 12. So 1, 3, 2, 6, 3, 9 and 4, 12. So these are the order pairs we need to consider for the relation, for the given relation. Now we need to check the types of relation, that means whether it is reflexive, whether it is symmetric or it is transitive. So first condition, first type of relation is reflexive relation. Reflexive. So in the last class I have given the explanation when we consider a relation as a reflexive relation, when for every element of the main set, all the elements should occur or should obtain in the form of doublet. That means all the elements should have its doublet. So in this main set, elements are from 1 to 14. So elements are from 1 to 14. That means all the doublets for the element 1 to 14 must be contained in the relation R. But here we have seen that these are the only order pair. That means 1, 1, this is the first doublet, is not present in R. Similarly 2, 2 is also not present in R. 3, 3 is also not present in R. 12, 14, 14 is not present in R. Yes, that means for every element of the set, main set A, its doublets are not present. So we cannot consider it is a reflexive relation. So what should be the definition? So since a comma a not belongs to R for every a belongs to a. So this is the symbol of for every. Since a comma a is not belongs to R, so doublets are not present for every a belongs to a. So the relation is not reflexive. So R is not reflexive. R is not reflexive. So what is the second type? This is symmetric relation. Now we will check whether the relation is symmetric or not. Now we will check whether the relation is symmetric or not. So next type is the symmetric relation. Next type of relation is what? Symmetric relation. Symmetric. So a relation in is said to be symmetric. In the last class we have discussed, in the last video we have discussed, the symmetric relation means every order pair in the relation. So these are, in this are, so these are the order pair, there are 4 order pair. So this relation is said to be symmetric. That means for every order pair it must have its reverse order pair. So here 1,3 is present. 1,3 is present in R, but its reverse order pair 3,1 is not present. Yes, 1,3 is present, but 3,1 is not present. Similarly, 2,6 is present, but its reverse order pair 6,2 is not present. Similarly for 3,9 also, 9,3 is not present. Similarly for 4,12, its reverse order pair 12,4 is not present. That means for every order pair in R, its reverse order pair is not present. That means it should not be the symmetric relation. So what should be the definition? If a comma b belongs to R, if a comma b belongs to R, does not implies b comma a belongs to R. If a comma b belongs to R, does not implies b comma a belongs to R for every a comma b belongs to a. For every a comma b belongs to a. That means for every order pair in R, it must have the reverse order pair. But since in this relation R, its reverse order pairs are not present, so we cannot consider it as a symmetric relation. So what is the last type of relation? Which is transitive. So after symmetric, we will check whether the relation is transitive or not. So third, number 3 is transitive relation. Transitive relation. So in transitive relation, we need to check for every order pair, we need to check the relative order pair. Okay, and after that we need to combine the both order pair to find out the third order pair. So what is the meaning of the line? 1, 3. So here 1, 3 is present in R. So what is the related order pair? 1, 3, 3, 9. Because why it is related? Because 1, 3 is the second element, and in this order pair 3 becomes the first element. So 1, 3 and 3, 9, we consider it as a related order pair. So 1, 3 belongs to R. Similarly 3, 9 also belongs to R. But when we combine this order pair, so we have discussed in the last video, when we combine the related order pair, we must get the third order pair. So which is the third order pair? 1, 9. But 1, 9 does not belongs to R. Is it clear to you? So 1, 3 is present, is related order pair. 3, 9 is present in R. But when we combine these two order pair, the third order pair 1, 9. So how can you form the third order pair? That day we have already discussed in the last video. The first element of the third order pair is from the first element of the first order pair, and the second element of the third order pair is from the second element of the second order pair. So after combining these two order pair, the third order pair, that means 1, 9, which is not present in R. Yes? So after combining the related order pair, the third order pair is not present in R. That's why we cannot consider R as a transitive relation. So what should be the definition? For A comma B belongs to R, B comma C belongs to R, this does not implies A comma C belongs to R. For all A comma B comma C belongs to A. So it is not a transitive relation. So here R is not a reflexive, not a symmetric, is not a transitive relation. So in the next video, we will discuss few more examples from the exercise relation and function. Thank you.